Alright guys, welcome back to our second part of 5.4, and we're just going to go over two examples today, but they are a little more in depth and they require a little more thought, so they're really important. So make sure you take notes on this one and make sure you're actively listening and involved, because if this is one of those times where it's like, especially on the second example, if you blink you're going to miss it. So example 3, a regular pentagon is inscribed in a circle with diameter 8.34 centimeters. The apothem of a regular polygon is the measure of a line segment from the center of the polygon to the midpoint of one of its sides. Find the apothem of the pentagon. So this is one of those things where it tells you what something is, and you have to draw it, right? So we know, I'm just going to start drawing. We have a circle, down a little bit, and a pentagon is inscribed. So let me do my best. I wonder, maybe that's good enough. And if you just make a quick sketch, that's okay too. I actually did a pretty good job. So inscribed means they're all supposed to touch. I'm not going to fuss with it anymore. That's actually pretty good. So, and then it says, what did it say? It said the apothem of a regular polygon is the measure of a line segment from the center of the polygon. So maybe the center is pretty close to there, to the midpoint of one of its sides. Well, let's just draw it down to that midpoint of that side. Find the apothem of the pentagon. So this is what we want. I'm just going to call it A for apothem. That's what we want. Now, somehow with this information, we need to find how long that apothem is. And at first, it might seem like, well, how are we supposed to get that? But I'm going to draw one line in. And this is the kind of thinking of math where, like, sometimes you have to be a little creative. I'm going to draw one line in right there, right? And when I draw that line in, we happen to know that that is the radius of that circle, which is 8.34 centimeters. So this is 8.34. Ooh, one other question. So to find, or correction, actually, it said the diameter, right? So that's the radius. So it's actually 4.17. So good catch there by me, right? It's important to read your problem and make sure you have everything lined up how it should. But now, something we need to think about is, well, we can't get this, we can't really get that side right there. We know we've made a right triangle, which is good. But what we really need is we need an angle somewhere, right? Because in previous examples, we needed angles to find other measures. So here we need to do the same thing. And we know one of these angles, right? If I draw in that side, we can then think that that is going to be 1/5 of 360. So 360 divided by 5, we know that's 72 degrees. And we have half of that right here with this angle. We have half of 72. So 35 to 35 is 70, so 36 degrees. We know that that right there is 36 degrees. And now it's just a matter of plugging it into our calculator, right? And we have to find out which trig function to use. So we have sine, cosine, and tangent. Now, which one, in reference to this 36-degree angle, involves the hypotenuse, and our apothem is going to be our adjacent side. So we need adjacent and hypotenuse. That's going to be cosine. So cosine of 36 degrees equals SOHCAHTOA adjacent, which our adjacent is our apothem, over hypotenuse, which is 4.17. And then we simply solve for a by multiplying 4.17 over 4.17 times cosine of 36 degrees equals a. And when we punch that into our calculator, we should get, again, I'll make the about symbol actually, 3.37, and then we're in centimeters. So that one's not too bad, but this next one is super in depth, and we need to be really careful. So, on May 18th, 1980, Mount St. Helens, a volcano in Washington, erupted with such force that the top of the mountain was blown off. Interesting fact, but in a problem like this, I don't care. That tells me nothing I need to know. To determine the new height of the summit at Mount St. Helens, a surveyor measured the angle of elevation. Okay, so don't need that, don't need that, don't need that. This looks like it might be important. The angle of elevation to the top of the volcano to be 37 degrees. So we have angle of elevation, 37 degrees, 46 minutes. The surveyor then moved 1,000 feet closer, so moved 1,000 feet closer to the volcano and measured the new angle of elevation, or I should probably color code that with green. That makes a little more sense. So the new angle of elevation to be 40 degrees and 30 minutes. Determine the new height of Mount St. Helens. So for something like this, I like to draw a picture. Now, we know we're dealing with triangles. And I'm just going to start drawing what we know. So we have some sort of mountain, right? That's going to be my mountain. And we have some guy. We have some guy out here, some surveyor, some distance away from that mountain. And he's measuring to the top of the mountain. And he finds this angle right here. He finds this angle to be 37 degrees and 46 minutes. Right away, I'm just going to put that in degrees. I'm going to divide 46 by 60. And that's going to be 37.76 repeating degrees. Right? And then it says he moves 1,000 feet closer. So I suppose here, I'll color code my mountain here. I'll make it more obvious if that's the mountain, that the blue is the triangle. And now he moves 1,000 feet closer, so he's going to be closer to it, and he does the same thing. He looks to the top of the mountain, right? And then that angle there, let's see, we kind of have two triangles here. That angle there is then 40 degrees and 30 minutes, which is the same thing as 40.5 degrees. And now, from here, we know that this distance is 1,000 feet. Because it said he moved 1,000 feet closer. And then I just like to label things that we don't know. Since we're going left and right, almost as if we're on an x-axis, I'm going to label this remaining piece x, and then this height, a good letter for height is h. So we can call this h over here. And that's how you should kind of draw a diagram when you're given information. Now, this would work perfectly fine, but I'm gonna just get rid of it. I just want to like go through with you guys on how to dissect a work problem and create your own diagram. But just for the sake of lecture, I'm going to take the picture from the book because it just looks a little nicer, right? And I'm just going to stick it there just because it looks nicer. And we could work with that a little better. And I'm actually going to cut the end off. That way I have as much space as possible. So, determine the new height of the mountain. So we are looking for h, which is important. Now, to get h, we kind of need to use this inside triangle here, right? But to get it, we would need to know x. So first things first, we need to find x. And to use that, let's look at this larger triangle, which I'll outline in a different color. This larger triangle, we got two triangles going on here, two different right triangles. Right? So, we're going to have to create two different equations. First, let's involve this 37 degrees, 46 minutes, which was the same thing as 37 degrees, and it was 0.6 repeating, 7, 6 repeating, 7, 6 repeating degrees, and then this is 40.5 degrees. That one. Now let's just use our trig that we know. Sometimes these problems are just like use what you know until you get there. So I'm gonna use this 37.76 degrees. And I'm gonna say I want to involve the h and when I don't know anything about the hypotenuse, so nothing hypotenuse, so I'm gonna want opposite and adjacent, so I'm gonna use tangent. So tangent of 37.76 degrees equals opposite is h, and adjacent is going to be 1000 plus x, right? And now I'm going to solve for h by just multiplying that 1000 times x over, or 1000 plus x, sorry, times the tangent of 37.76 degrees. And now that's what I want. I want h, but we don't know what x is, so that's the problem. So now we're going to go to this other triangle, and I'm going to use this 40.5 now. So same thing. I don't know what anything is. So I have to use x and h. So no hypotenuse. So we're going to use tangent again. And this time it's 40.5 degrees. And our opposite is still h. And our adjacent there is just x this time. And now I have two equations with two unknown variables. What am I going to do? I'm personally, since I have h solved for right here, but I think it might be easier here. I don't know. There's kind of two ways to go about it, but I think what I'm actually going to do is I think I'm going to solve for x in this one and then plug it into that equation. So I'm going to multiply that x over and then divide the tangent of 40.5 degrees, and we'll get x equals h all over tangent of 40.5 degrees. Oh, that's actually kind of nice now that I think about it, because here we have h, right? So let's just plug in what we know for h. H is 1000 plus x times the tangent of 37.76 degrees repeating. Oh boy, that looks like a lot, doesn't it? Well, once we kind of think about it, these two things are just numbers, right? So I'm going to do that first. I'm going to take the tangent of 37.76666, and I'm going to divide it by the tangent of 30.5. And that's going to leave me with x equals 0.907 times 1000 plus x, and then times 10 would be moving this decimal over, 100, 1000. So we're going to get, when we distribute, we're going to get 907 plus 0.907x. Subtract the 0.907x over, and we're going to get 0.093x equals 907, and then divide by 0.093, divide by 0.093, and then we're going to get x is 9,752.688, is where I'll round it. And now we can use that in another trig function, right? So now we have this x to be 9,752.688. Now we can use that, right? Now we can use that for our tangent. So we already have this h equation right here. We can just plug x straight into there. So we have h equals 1000 plus x, which is 9,752.688, times the tangent of, was it 37 degrees? Yeah, 37 degrees, 37.76 repeating degrees. And again, that's just another thing to just type into your calculator, right? So we add 1,000, and then we're going to multiply that by tangent of 37.767, and we should come out with the height of the mountain is 8,000, I should say about, because we approximated 8,330 .625, and then we were in feet. And I'm just going to check the book to make sure that's where we got. And we're about in that range. It's not exact, but that'll get you there. And this was a lot, and there's a million different ways that you could do this problem, right? Up here, you could have solved for x, and then you could have put h in for x, and you could have done any number of things, right? But this is one of those ones where you just kind of have to think through it, and I was kind of just trying to get you to think through it. So my advice for these ones is, number one, draw a picture and label everything. That should be like number two on its own. Label everything you do not know. Just label it, and then Number three is just use what you know, right? Use the trig that you know until you get there. But that is going to wrap it up for 5.4. I know this last problem was a little crazy, so don't be afraid to ask me questions. But yeah, next time in 5.5, we will get into solving right triangles.